Welcome to the first video of the FRC Programming series presented by Team 1257. In this episode, we'll start with a high-level overview of everything you need to know about the robot in general to get started with programming. Here you'll find all the information in our training resources. In order for the robot to operate, it must be connected to a driver station or a laptop, which has two Xbox controllers, which give the robot controller inputs and basically make sure that the robot isn't doing anything dangerous. Now, in order to send information back to the driver station, the robot uses something called the network table, which basically transfers data two ways between either. When we're actually on the field, there's another system called the field management system that commands the robot when to start different modes, such as like teleoperated, autonomous, or to be in the disabled mode. And this system also uses the network table so that everything else knows what's going on. Okay, the last part of the system is our co-processors, which can be a Limelight or Photon Vision. And basically, these are other extra computers that we use on our robot to give us extra data. So later we're going to talk about vision data, and these co-processors give our robot information that is important to do things in the future. So right now we're specifically going to look at driver station, and this is what this is the driver station, and this is how we run code on the robot from our laptop. This is what the icon looks like, and it allows us to basically see everything that's going on in the console from the robot code, and also change the robot operation mode from teleop, autonomous, practice to test. We can also connect to it via here and see the communication status as well as the joysticks here. And another important point is that you can enable or disable the robot here. So when the robot is enabled, it's on. And if you want to quickly disable the robot so it doesn't hurt anybody, you should press the enter key on the laptop. In case of emergency, if you can't press the enter key, you should press the space bar. This will emergency stop it, and it's much harder to revert an emergency stop. Okay, this next tab in the driver station is the communications tab, and it shows you basically everything you need to know about your RoboRio, the processor running the robot code, as well as how you're connected to the RoboRio. You can also restart the robot code if there's ever an error, and restart the entire robot if anything electrical goes wrong. The next tab you don't need to worry about too much. It's just where we set our team number so that the driver station knows how to connect to the RoboRio, and then also some additional configurations for other modes. The next tab is the USB joystick tab, and basically here you'll be able to see all the joysticks connected to the robot. Here you can see the two Xbox controllers we use. The first one is the driver controller, and the second one is our operator controller. And so if they're ever not in the right order, you can drag them around to see what's connected. And here, when you press on a controller, you can see what values it's outputting. This next tab is just some electrical things. You can see can chain values, we'll talk about that later, and then some power information. Yes. Okay, now let's look at how we give the robot inputs from our driver station to the robot. So, as I mentioned before, we use Xbox controllers, and with any controllers in general, there's basically two types of input. There's digital input from buttons. So like that would be like these buttons over here, these buttons, the D-pad or the bumpers on the controller. And those are only 0 or 1 values on or off, Boolean values. The next set of inputs are called like analog inputs, and these can range from like -1 to 1 or 0 to 1. So a common like example of that would be like a joystick. A joystick has two axes like X and Y, so it's actually two analog inputs in one joystick. Okay, now let's look at specifically our robot. Okay, this diagram looks kind of scary, but don't worry, it's not our job to know everything here. So here we have our RoboRio, which is the processor for our robot, and it's connected to everything else on our robot, like the limit switch sensor, our servo, as well as the CAN chain, which is the green and yellow wire, which connects to all our different motor controllers. And then the other big rectangle at the center of the screen is the power distribution panel, and this allows us to power all of our motors. And other external gadgets. Here's another diagram. Here's a PDH. And as you can see here, there's a lot of things that you have to control on a robot. So it's important to program it all well. Okay. Okay, so from all that electronic stuff on the robot, the only things that we care about are our motors and our sensors. And so basically, as programmers, it's our job to decide how we take all of the inputs and outputs that we can get from our robot to do what we want the robot to do. Okay, so you may be asking, what is a motor controller? This is what the motor controllers we use look like. That's a CANSPARK Max motor controller, and basically this is power cable feeding it, and then this power and signal cable goes to the motor. So we mainly use like Neo 550 motors or Neo Vortices, and basically these motors have built-in encoders as well that you can plug into one of the ports on your motor controller, and it allows the motor controller to basically control these like brushless motors. Another thing you can add to the motor controller is an optional like alternate encoder. So this is like a through bore absolute encoder. And so the difference between this encoder in the motor and the absolute encoder is that absolute encoders can remember their position after you turn the robot on or off. So this is really important for mechanisms where knowing the true position is important. Okay, now here's another piece of software that's like pretty important for us as a team. It's called the Rev Hardware Client, and it basically allows us to configure a bunch of things on the motors. So, you know how I was saying before that we have like a CAN chain, right? Now, for all the motor controllers that are connected in this CAN chain, they all need to have a different ID, and you need to use this software in order to configure the ID and a bunch of other things on the motor controller, like the motor type, brake mode, and other limit things. Okay, now another section you might want to like look at in the Rev hardware controller that we may ask you to use to test motors is the run tab. And basically, you can move this slider around, and when you press run motor, then it'll run that motor at that set speed. So while you're using the Rev hardware client, all you need to do basically is just plug it in via USB-C to the motor controller, and then you'll be able to access these things. But anyway. Another important concept is that of PID, and basically that's the idea of how our mechanisms can move to set positions. So like you see here how this guy moves this thing to either side. Once he lets go, this thing tries to get to its like set position. And this concept of PID is really important in robotics in order to control how motors move itself. And we'll get into detail later, like what each of the terms do, but it's basically the idea of tuning the three P, I, and D values to make a controller that fits your needs. So that software was specifically for CANSPARK Maxes, but depending on the types of motors we're using, you may need different like software. So this is the Phoenix Tuner X by Cross the Road Electronics, I believe. And basically it's the same thing, but just for these guys is like motors and motor controllers. Okay, so here are some different kinds of sensors. So this image is basically represents like a gyroscope, and it'll measure your roll, pitch, yaw in 3 dimensions. So you can measure your angle in all those different ways. This is a limit switch. It's like a button. And this is a brake beam. It sends one beam of light to the other, and you can detect if anything is stopped it in the middle. The way we program the robot is we take all of these motor controllers, all of these sensors, and we divide them up into different subsystems. And so, say, like for our drive subsystem, for example, we might have 4 motors for that. And we put all of the code for all those 4 motors in the drive subsystem. And then when we want to reference them in our robot code, we can say, hey, drivetrain, move forward 1 meter. And so we don't have to say, like, motor controller one move forward 1 meter, motor controller two move forward 1 meter, like and etc. You can just say drivetrain subsystem move forward 1 meter. And so this is an idea called abstraction, where we're basically saying the control for all 4 of these things, which is like kind of complicated, goes to this one thing. And then in our robot code, we say, hey, I want this one thing to do something. And so basically we do the same thing for all our other subsystems too. And you can see here in this claw subsystem, it also has a brake beam sensor. And so you can control a bunch of things in a way that's like easy to understand. We're not going into too much code here, but the idea of like splitting things into subsystems is also that things are going to be in different states. And for example, for a pivot, you might want to like manually control it, say go up or down, but you also might want to tell it to go to set positions, which is what PID is. And so you can use something called commands that tell the subsystem, hey, do this for a certain amount of time. And you can bind, like, for example, the manual command to a like an analog input. So basically, you can make it so that if the joystick moves up, the pivot also moves up. And so taking like the controller bindings, controller inputs, along with the commands, along with like the update method in the pivot arm together, you can do some like really cool things. Programming the robot to move around is only part of programming's job. We also need to include extra advanced features like trajectory planning to move the robot in the ways that we want it to, and also log important features from our matches so that we can troubleshoot when things go wrong. Things go wrong a lot, so you need to be ready for when that happens. These features don't exist just to look cool, but they also serve a purpose. This here, for example, is a log where our drivetrain wasn't working, and we use this log file to diagnose our problem. Another thing that's really useful for a robot is like pose estimation. And the idea there is basically we use this camera with our coprocessor and it looks at these April tags and it can detect where they are in 3D space and figure out where the robot is basically. And so these cool features really like improve our robot, like our efficiency, I guess. Okay, so another really important part of programming is programming our autonomous. So this is this year's robot, and as you can see here, like this is the autonomous round. The pivot is pre-programmed to move up and also shoot. So breaking things down into their subsystem stuff. The pivot is being given a command to move up to its set point, and at the same time, the shooter wheels are being commanded to spin outwards. And then once everything is ready, then the intake will bring the note into the shooter to fire it. Okay. Now the last step, we'll look at network table clients. And basically, these are just like how the driver station, the laptop, looks at the things that are on the network table. So one like really common like network table client or dashboard is Shuffleboard. It comes with WPILib, and you can basically see everything here. So here's some drop downs, here's some buttons, and then here's where the robot thinks it is. And so basically you can set everything there. You can also tune PID values. We'll get into that later, but you can do a bunch of really cool things. You can also see camera streams in the shuffleboard. And another really cool like network table client is Advantage Scope. And so it has all these cool features. So you can see the network table on the side here when it's connected. You can drag things in there into the data inputs. And they have a bunch of different kinds of tabs to visualize different things. So in this case, we're looking at the 3D field visualization. And so it'll show you like the visualization, the match timeline, and then you can go through all the logs. Advantage Scope is included with our FRC tools, and it's a really nice resource. So here's an example where we're using Advantage Scope to basically test our robot code in simulation. So, simulation is basically when we're running the robot code on our local laptop without actually having physical access to our robot. And this software is just giving us everything that we would see on the actual robot. So here you can see me drive it around. There's a trajectory to go to the amp. And it's Advantage Scope is basically allowing us to visualize. We have our robot CAD in there and everything. What's going on the robot? And you can also see those lines there where it's shooting out notes. Okay. In this example, we're visualizing a log file from when we tested our autonomous on the robot. And you can see some things here, like the robot's oscillating a bit, its pivot arm is like shaking, just like it did in real life. So Advantage Scope is really cool since it allows us to do these cool things. Other teams also have their own custom dashboards, and they look pretty cool, just like this one. One custom dashboard that we like to use is called Elastic, and it looks just like Shuffleboard, but has a more modern interface. Here you can see some drop downs, camera streams, and field layouts. And here's another example with a graph. Okay, lastly, let's talk about our vision. And our coprocessors run a software called Photon Vision, which allows to choose between multiple different targeting modes for our cameras. The gold standard in FRC is to use the Limelight, which has a processor, camera, and lights built in. But our setup has a Raspberry Pi and a couple of USB cameras. And we found running Photon Vision that's all we need. That's all that we want. With all this information, you may be asking, well, how do we do our jobs as programmers? And we do this for the most part, WPI VS Code. And basically, when you download the FRC game tools, it downloads a library called WPI which has all the extra code that we need to run our robot. And then you code in an environment called Visual Studio Code. And that basically allows you to look at all of our files and also run WPLib specific tasks. That's the WPLib icon right there. And later on, we'll talk about what all of these files mean and how they're important. That's all that we wanted to cover in this episode. Stick around for the next one where we'll cover basic Java syntax. Thank you for listening and have a nice day.